To understand and predict processes and activities, we have to be able to analyze multimodal data through both space and time. To address this need, ENVI has a new capability for spatiotemporal analysis. Here we will look at a part of that capability, the visual exploration of time-enabled rasters. Analysis of vegetation land cover is a key task in remote sensing, and one of the most commonly used science datasets is the MODIS 16-day Global Normalized Difference Vegetation Index. In this image we see NDVI over the Great Lakes area. There are noticeable variations across space, for example higher values near the coast. The series of NDVI allows us to see that there are also variations in vegetation over time. As we step through the series, we can see an expanding region of high NDVI as we move from winter to summer. Another way for us to see this is just to drag a copy of our series into the same display and open multiple sliders. Setting one to winter and one to summer, we can then use transparency to quickly see the changing vegetation characteristics. To really highlight this, we can also change the color table, and we can add a dynamic annotation. And in this way, we can examine variations in vegetation over both space and time. In this example, we will examine the National Centers for Environmental Prediction, Department of Energy Reanalysis 2. This is a global atmospheric dataset combining model and observations from 1979 to the present. I've set up two views, and in the left we see an image of global temperature near the surface. We can immediately see the variations in temperature over space, with a dominant pattern of higher temperatures near the equator and cooler temperatures near the poles. Each of these frames from the reanalysis consists of 124 parameters, including temperature, winds, and humidity at different levels in the atmosphere. To compare these, just drag a copy of the series into the second view. And then we can, for example, change our parameters to the zonal component of the wind. We can update the color table, add an annotation, and then view this with multiple sliders and control these independently. Alternatively, we can link these two images in time. And now, as we step through the series, we can see how temperature and winds change over both space and time. Once these views are linked, another way we can actually view this is by exporting as a video. And there are a number of options, by default AVI, but also some advanced video save options. This is a video generated from this raster series. And in this way, we can really see the complex patterns of the atmospheric parameters and how they vary over both space and time. While data represented on a regular grid is ideal for some types of spatiotemporal processing, in other cases, the remote sensing platform might be imaging different locations over time or tracking a moving object. In this case, the series will show us a time sequence of images that change their spatial location. So in this example, we see a series that was extracted from a video acquired by UAV. The video also contained metadata, so the series preserved the spatial and temporal information. Each image reprojects to the established base map. To see the original image, we can set up a new view and drag a copy of a series into the new view. Without the base map, the image has the same geometry as when acquired by the UAV. We can then add a dynamic annotation, and we can also link these in time. And this allows us to be able to clearly see the object of interest and also view its location. We have new tools in ENVI that allow you to easily build a time-enabled series, and these examples explored some of the ways that spatiotemporal analysis in ENVI can be used to better understand processes and activities.